Hi guys, so I'm not here today. I am in Wisconsin, so hello from the cheese state. So we're going to go over your Bellringer really quick, which was describing the three laws of motion. So the first law is the law of inertia, and the law of inertia tells us that objects in motion stay in motion, where objects at rest will stay at rest, unless they're acted on by an external unbalanced force. So a good example of this would be like my marker right here. Right? If I have this marker, you can see that the marker is not moving at all, right? That's because there are no external unbalanced forces acting on it. If I were to push this marker, the external force is my finger, and therefore it will move, right? So it moved as a result of the external force, my finger. But the reason why it didn't keep moving and moving and moving, like it says in Newton's first law, staying in motion, is because there was an external unbalanced force working on the marker after it moved. Friction is what slowed it down. So friction is acting as an external unbalanced force. All right, so the second law is, as simply put as I could, is F equals ma. All right, when mass increases, force increases. When acceleration increases, force increases. So I gave you two examples. The first is if you had a bowling ball and a ping pong ball and you threw them with the same speed, the bowling ball is going to have a lot more force behind it, whereas the ping pong ball probably won't have as much force behind it because it's a lot lighter. It has less mass. So let's look at another example with acceleration, right? If we had two ping pong balls and one of them we just kind of tossed and the other one we whipped it as hard as we could, both of these objects have the same mass, but the one that has the higher acceleration, like in F equals ma acceleration, this one is going to have a higher force. All right, so the third and final law is for every action, there is an equal and opposite reaction. So I like to call it the action-reaction law. So for this one, we actually see this a lot when you're like rolling on something. So for instance, when I push on this desk, I roll backwards. The action is me pushing on the desk. I am applying a force to the desk. The reaction, as weird as it sounds, is the desk pushing back against my hands, which is what's pushing me backwards, okay? If the desk didn't push back on my hands would go right through the desk, all right? Likewise with the floor. So we have a force of gravity acting on us all the time, right? That's why we have weight. If we had all this gravity on us, there needs to be something holding us up. So if the ground force wasn't pushing back up in reaction to our weight, we would fall through the floor, okay? So those are Newton's three laws. If you have any questions, make sure you ask Mr. Janke.